To contrast this, let's go to the case of the IIR filter. Over here the data flow graph looked like this, S, right. So what is happening over here, the output of A is the Y, right, the filtered output. One delayed version of it is what goes as input to the M, which is basically multiplying by the coefficient small a, right, and that value is being fed back into the adder, okay, which is also in turn adding whatever it gets from the source, which is x of n, right. Let us go through the same process, right. So at t equal to 0, S fires n times, okay. So I have S0, S1 up to Sn minus 1. What does the graph look like as a result? S, I have n times d sitting over here. Okay. All right. I could have also fired the M, but it does not matter. I am just going to sort of take one step back and say, all right, let us just separate it out, right. At t equal to 1, let us say M fires, how many times can it fire? It can fire only once, right. So it basically only M0 can fire over here. What ends up happening as a result is, I have this n delay sitting over here. It is just that the one token that was at the input of the M now comes to the output of M, okay. At t equal to 2, now M cannot fire anymore. S of course can fire at any point, but I have already generated n output token, so I am not going to really bother with it at this point, right. A can fire, again it can fire only one time, because it has n tokens sitting on one of the inputs from source, but on the other input which is coming from M, there is only one token sitting over there, okay. And my graph now looks like this. D comes at the output over here. What about the S to A edge? It becomes n minus 1 D. Okay. I can take this forward at t equal to 3, M, that is M1 fires. Right, and at t equal to 4, A1 fires, and this becomes n minus 2, okay. So you can see where I am heading with this. Essentially it becomes very clear that in order to finish off those n tokens that were generated, or in order to bring the graph back to its original state, the S to A arc has to go down to 0. For that to happen, I basically need to go through this process n times, right. N times A has to fire, n times M has to fire, and they can happen only one after the other, okay. So this is essentially what will happen. Right, after a total of 2n plus 1 clock cycles, right, time steps for n iterations of the data flow graph, which means that the iteration period average becomes 2n plus 1 by n, which tends to 2. Okay. So, hopefully by now it is clear that this is not just something that happened because of the way that I decided to execute things. This is in some ways a fundamental difference between the IIR and the FIR filters.